Okay, let's start with the example. So hopefully, like when you have a look at the example, so it will help you to understand better about like how to find the domain and range for the functions given. So let's start with A, for which you have f of x is equal 3 minus 3x. So here I have a function for which x is raised to the power of 1, and we know that this is called as a linear function when you have x to the power of 1. It is one of the polynomials function. So when you want to talk about the domain, so the domain is going to be like, the idea is that what is the possible value for x? And we have seen this before, like this is not a fraction, this is not a square root either. So the thing is that there is no limitation for the value of x. So the value of x could be anything. So let me put it here. So the value of x could be anything. Could be anything. If you substitute any value, it would have given you a real number for sure. So that is why I can write that. So what is going to be the value of the what is going to be the domain? So the domain is going to be any value that goes from negative infinity until infinity. So that is going to be my domain value. And what is going to be the range? The range means if I were to substitute the value of x over here, so what value is possible for this whole function right here? And of course, when x could be any value from negative to infinity, the outcome, when I substitute the value of x in 3 minus 3x, the range could also be any value, so which is from negative infinity until infinity. There is going to be no limitation. So that is why if we sketch a graph of linear, this is going to be 3 minus 3x. So the graph is somehow is going to look like this. So it covers all the x value, it covers all the y value. So that means that it covers from negative infinity until infinity. So that is going to be for the first function. And for the second function b, I have gx. So my gx is equal, it's a rational function of 3 over 2x minus 1. And now it's a fraction. And we have seen before the fact that when you have fractions, there is a limitation for that. But before that, before I forgot, let me put over here. So domain and range from negative infinity to infinity. This is always the case for linear functions. The case, before I forgot about writing this down for you, the case for linear functions. Okay, now let's get back to B. So this is a fraction, 3 over 2x minus 1. We know that for fraction, the denominator should not be equal 0, because if I have something that is 3 over 0, automatically this is going to be undefined, and that is not going to be a real value, and we don't want that to happen. So therefore, when I ask you what is the domain, what is going to be the limitation of the value of x, what x value that cannot occur for this case, so I can write that. So our calculation is going to be, so 2x minus 1, the denominator, so the value cannot equal 0. And when I simplify this, I will get that x cannot be a value of 1 over 2. So when I write down the domain, I can write this actually in terms of two ways. So I can write that the domain, the x value, so it could be any value from negative infinity until a half, and union, so the value from a half until infinity. Let me clarify a little bit on the value of, on the usage of the round bracket and the square bracket. I'm sure you know this already, but this is just a reminder for you. So this is called a round bracket, and this is called as a square bracket. So you use round bracket for the case of infinity, because we don't know for sure what the value of infinity is. Is it 100 of 10 million? Or is it like going to be 100 million billion? So it's going to be a very, very big value that we are uncertain. So that is why we use a round bracket. Or it could be value that is not included, which for this case, if I refer to the 1/2 over here, so 1/2 is not included. It cannot be 1/2. So that is why I'm using a round bracket. But if I'm using a square like this, mean that the value that goes after that is included. So if I have, for example, bracket of 1 means that 1 is one of the value that is included. Or, so if you don't want to write like this, you can also use another notation, so which is going to look something like this. You can write, put a curly bracket. So x is possible, it could be any real number such that so x cannot equal 1 over 2. So this is also possible. So basically this two exactly means exactly the same thing. And this straight line over here, so it means such that So it's going to be x is all real number such that x cannot equal 1 over 2. Okay. All right, so that is going to be the domain. And what about the range? And how do we find the range? And I have written over here, how do we find the range for case of rational functions and what do you call that, reciprocal. That first we're going to let y equal f of x and find x. Solve for x means we're going to find x. X is going to equal what? So the range of all y values for which the denominator is not equal 0. So now that's the method we're going to use. So the first step is I'm going to let y equal 3 over 2x minus 1. So this is going to be the first step. Okay, and then what I'm going to do is I'm going to find x. So how do we find x? So I'm going to manipulate the function. So I'm going to have that 2x minus 1 is going to equal 3 over y. So x is going to equal 3 over y minus 1 over 2. Sorry, it's going to be plus 1 over 2. Or I can actually write that, you know what, let me put it in simpler way for you. I might be able to calculate this, but it's not going to be obvious for you. So this is going to be 2x is going to be 3 over y plus 1. Or I can actually write that this is going to equal 2x is going to equal 3 plus y over y. So my x value, so that is going to equal 3 plus y over 2y. So now I'm going to have a look at like what is the limitation for this case. Okay, what value is not possible for y? So that is going to be step number 2. So what value not possible for y? Okay, so when I have a look over here again, so this is in terms of a fraction. So we know that when we have a fraction, the denominator, it cannot be 0. So meaning by, in terms of our calculation, we know that 2y cannot be equal 0. So the y, the value cannot equal 0. So that is y. So in terms of the range, what is going to be our range value? So that is going to be from negative infinity until 0, union from 0 until infinity, or the other notation. I can write that y could be any real value such that, so y cannot be a value of 0. So that's how it goes. Okay, so that is going to be our range. So that is for B. So now let's move on to C. So for C, I have h of x, which is equal to square root of x plus 1. And we have seen the limitation for square root as well, as I've written up there. So the fact that when we have a square root, so the inside of the square root cannot be a negative number, because when you square root a negative number, so what will come out is going to be a complex number, and we don't want that. So therefore, so when we wanted to calculate what is going to be the domain, so we know that the function inside x plus 1, it must be greater than or equal 0, meaning that it must be 0 and positive, but it cannot be negative. So this is going to be the case when x is greater than or equal negative of 1. All right, so that is going to be our domain. So meaning that our domain, it should be from greater than or equal negative of 1. The smallest value is going to be negative 1. And because of this sign over here included, so that is why I'm going to have a square bracket. So it's going to be from a negative 1 until infinity. Of course, when it comes to infinity, so it's going to be a round bracket. Or I can also write that in terms of the set notation. You just have to pick between one of these. You don't have to write both of them. Just one is enough. So I can write that x is going to be all real numbers such that x is going to be values greater than or equal negative of 1. So any of this is going to be perfect for me. Okay, so that is going to be in terms of domain. And what about range? Okay, so we know it already. So for the case of range, we know that the smallest possible value in here, it could be value of 0. And we know that square root of 0 is going to equal 0. So for the case of a square root, the range is always going to be from 0 until infinity. Always the case. So let me put over here as a reminder for you. So whenever you come across a square root, you don't have to think further about the range. It's always going to be from 0 to infinity for the case of square root. Always the case when you have square root. So let me put a square root symbol instead. Okay, so that should be clear to you. Domain, it will change, but square root, but a range, it is always going to be from 0 until infinity. Okay, let me add another page. Now let's go to D. So for D, we have kx. So kx is going to equal negative of square root x plus 1 again. So there's not going to be much difference in this. The only thing is that the range will be different because we have a negative outside. Okay, let me explain to you in detail here. So again, what is going to be the limitation when we have square root? The inside here cannot be a value of negative. So therefore, I'm going to have the same calculation as before. No, that's ugly. So I'm going to have x plus 1 is greater than or equal 0. So x is going to be greater than or equal negative of 1. So automatically, what is going to be my domain? So my domain is going to be from negative, and sorry, it's not going to be from negative infinity. So it's going to be from a negative 1 until infinity. So that is going to be the domain. And what about the range then? Okay, for the case of the range, okay, so what happened is that we know the range is going to be from 0 until infinity because the smallest possible value over here is going to be 0. And when you square root a thing, it is always going to be a positive number, but you have to be mindful about this. So whatever number that comes from is always going to be negative. For example, if I have a negative of square root 9, of course the number inside here is positive, but when I multiply by the negative outside, it's going to be negative of 3. Or if I have negative of square root 100, of course it's going to be 10, but because of the negative right here, so I'm going to have a negative of 10 as the outcome. So that is why for this case our range is going to be the same as before, but it's going to be negative of this value. So that's why it's going to reverse. So the range is going to be from negative infinity until 0. So the highest value could be 0. Other than that, it's going to be negative because of the... Alright, so next we are going to have a look at E and F. But the thing about E and F is that it involves what I call that quadratic function. For the domain, there will be no problem. But remember for the case of range, so the range is going to depend on either the minimum value or the maximum value of the function itself. So therefore what we have to do is, so you have to know how do you find the minimum value and also the maximum value for the case of quadratic functions. So what you're going to do is basically the concept of completing the square. So that's going to be one way. But there's actually an easier way to do this, which is by using a formula. So the formula is actually derived from the concept of completing the square as well. I'm not going to derive that for you in detail. You can try that on your own if you want. And if you're really interested in that, you can ask me personally. But for now, I just want to give you the shortcut way. So which is by simply, it's going to be sort of like a formula. But the idea is going to be completing the square. Okay, what happened is that, so if I have a function in the form of ax squared plus bx plus c, if I wanted to know what is going to be the minimum of the maximum point of my quadratic function. So remember when we have coordinate and we want to locate the position, so we have x and y coordinate. So the x coordinate is going to be given by a negative b over 2a, right? And when you wanted to find the y coordinate, you simply have to substitute the value of f negative b over 2a into the function. So instead of having a function of f of x, so that x is going to be replaced by negative b over 2a. So the value we're going to find, so it's going to be a number now in the form of negative b over 2a. Alright, so let's start with the first one. E, I have qx is equal x squared plus 4x plus 1. So this is to the power of 2. We know already this is polynomial function, a quadratic to be specific. And for the case of polynomial function, the domain is always going to be from negative infinity until infinity because there is no restriction for value of x. The value of x could be anything. And then next what I'm going to do is I'm going to find what is going to be the minimum value, because for this case my a value is going to be 1, and I know that when a is greater than 0, so it's going to be a small graph. I don't know whether it's going to be this way or that way. Now we will know by actually finding the minimum value and figuring out where it is. So now I'm going to start finding the minimum value. So the x coordinate, so it's going to be negative b over 2a. And for this case, what is going to be my a value is going to be 1. My b value is going to equal 4. Okay, so for this case, I'm going to substitute. I will get negative 4 over 2 multiplied by 2. So it's going to be negative 4 over 2 multiplied by 1, so which is going to be negative of 2. So that is going to be my value of negative b over 2a. So when I want to know what is going to be my y value, so I need to find what is going to be the function f of negative 2. So what is f of negative 2? So my f of x is given by, so it's q of x for this case. It doesn't matter whether I'm using q or I'm using f. So all I have to do is substitute into this formula right here. And basically all I have to do is substitute that my x value now is going to equal negative 2. So therefore, when I do the substitution, so I will end up with 1 negative 2 square, so plus 4 multiplied by negative 2 plus 1. And when I do the calculation, so this is going to be 4 minus 8 plus 1, and 4 minus 8 is going to be negative 4 plus 1, that is going to be negative of 3. So now I get the coordinate. So the minimum value will be at negative 2, negative 3. Okay, so if I were to sketch this properly, so this is not going to be the exact sketching, it's roughly how it looks like. So negative 2, negative 3 is going to be somewhere over here. So this is going to be negative of 3. So my function is going to look like that. Okay, so meaning by, so when I wanted to find the range, so remember range refer to the what value? To the y value, which is referring to this. So the minimum value is going to be at this value, which is going to be negative 3, and the graph actually extends towards the infinity. So that is why for this case, what is going to be our range? Our range is going to be from negative 3, that's the lowest value, including negative 3, and it's going to extend until infinity. So that is going to be our range value. Right, so that is going to be for E, and F is also going to be a similar idea. So for the case of f, I have a function f of x, which is equal to negative 2x squared plus 8x minus 4 again. So this is still going to be what do you call that, a quadratic function. And of course, the domain is also going to be from negative infinity until infinity. Okay, however here, if you notice, my a value is going to equal negative of 2. So this is going to be a sour graph. It's going to look something like that. But I'm not sure what value is this. And now we're going to figure out. Right, so the x coordinate is going to be found by using negative b over 2a. And my b value for this case is going to be 8. So I'm going to have 8 over. So 2 multiplied by my a value is going to equal negative of 2. So basically I have negative 8 over negative of 4, so which is going to equal a value of 2. And when I wanted to find the coordinate of y, I have to find f of 2, okay? And my f of 2 is going to be negative 2 multiplied by 2 squared plus 8 multiplied by 2 minus 4. So this is going to be 4 multiplied by negative 2, that is going to be negative 8 plus 16 minus 4. So 16 minus 4 is 12. So 12 minus 8, that is going to equal a 4. Okay, so my coordinate is going to be 2, 4. So roughly, if I were to sketch the graph, 2, 4 is going to be, let's see, somewhere over there. So this is how my graph is going to look like, 2, 4. Okay, this is not the exact representation, but that will be the idea. So coordinate here is going to be 4. So now let's see what value does it cover on the vertical axis or the y-axis. So it covers from here until down here. Remember, it's a maximum value. The maximum value is going to be at 4. So that is why for this case, so what is going to be our range value? So our range value, that is going to be from negative infinity with a maximum value of 4. So that's the maximum where it could be. Okay, so that is going to be how you determine the domain and range. So of course, like the previous ones, that you can try to do this exercise right here.